All right, so we're going to talk about the properties of limits, which are pretty self-explanatory. We already talked about them earlier, and you all guessed them correctly because you're so smart, right? So now we're going to just, write it down officially. But first, our bell work, and I think that Joao knows the first one. The limit as x approaches 2. Yep, right here. All right, and then I think Mateo knows the other one. X approaching 1. Right, does not exist. Why?
Because there are positive infinity and negative infinity.
Exactly. From the left, we go down to negative infinity. From the right, we go up to positive infinity. Since those aren't the same infinities, there is no limit. Awesome. All right, let's talk about some properties then. What's up? Yeah.
And A means the same as
No. Does not exist means it doesn't exist. Not NA means not applicable, meaning like you can't do it. The College Board won't mark it correct. I probably would, but the College Board no. Okay, so we already talked about this one, but let's write it out in kind of, longer terms. So what this really means, because I want you to have somewhere that you can go look them up later, is the limit as x approaches a of f of x plus the limit as x approaches a of g of x, right? That's all it actually means, which if f of x is defined as L and g of x is defined as M, or the limits of them, sorry, then this would simply be L plus M, right? Now, in English, I'm not going to literally write the limit as x approaches a of f of x, but all this literally means is take the two limits and add them together, right? Like that's what we're doing. So when I say in English, I'm trying to say like, just what are we doing? Like, just, how would you describe this to someone younger and less intelligent than you? Okay. Now for g of x, well, or for f and g, when we subtract, it's exactly the same thing, right? So what we're going to do is take the limit as x approaches a of f of x minus the limit as x approaches a of g of x. Or it would become L minus M. And in English, this just means take the limits and subtract them. Okay? Why would we not bother writing it this way that we're showing what it's equal to? What's the reason? Like the way that I just wrote, why would we not normally write it that way?
Why would you not normally write it how we just wrote it?
The way in green. Yep. Why would we normally leave it the way it was typed?
Because it's shorter and it's easier to write.
It's more efficient, right? Usually as mathematicians, you guys, we want to be efficient, and all that green stuff is not very efficient. So let's come up with a better way to write it, and hence why we write it the first way. But it's important that we understand that it is both, because there are times where we'll need to separate it, or where it's long and ugly and we want to put it all together. All right, so for our next one, this would simply be the limit as x approaches a of f of x, all divided by the limit as x approaches a of g of x, which is really just L divided by M. And over here, take the two limits and divide them. Right? That's all it means. I think you guys can probably, you're getting the hang of it. So Manuela, what's the next one? Perfect. Now, what I'm going to do to make it really obvious is I'm going to put them in like big set of brackets like this, just so that it's really obvious that we're multiplying them. But yes, absolutely. And of course, that would just be LM.
Sorry, I have a question.
Yeah, what's up?
No,
You already lost it?
no, like for the next one.
Oh, for the next one. Well, I haven't even done it yet, man. So we're just going to take the two limits and multiply them. Now for our next, Okay, so if it's a constant, then all this means is that that constant, like the limit of a constant is, well, the constant. So if there's a constant times the function, that limit can just come out front. So this is the same as c times the limit as x approaches a of f of x. Because the constant itself isn't going to change. So this would be...
So there's no limit on the constant.
Exactly, yeah. Which means that then for number 7, if we jump down and look at that, this here is literally just equal to c.
But
Right.
that-
Why does the constant not have a, like what I know it's because it doesn't change, but how does that make it not have a limit?
The reason is because the limit, it's the limit as x approaches something. If x doesn't
So
exist,
that function has to be a moving function.
yeah, so if there is no x, then it's just whatever that constant is. It doesn't matter what x is approaching because x doesn't exist. All right, what does this mean here? This part would just mean that, I don't know, I guess like, take the limit and multiply by the constant. And then this bottom one is just that, yeah, it's just like, there is no limit. There is no limit without a variable.
But Mr. I have a question. If there is no limit, that would be like a 9, no? When they are asking for the limit, that doesn't
No, because it's x approaching something. But if x is approaching something and x doesn't exist, it's just whatever else is there. So in this case, c, a constant.
But that would be not a limit, but like a
I mean, it's technically still a limit. It's just that there is nothing to take the limit of. So that's why we effectively just don't do it. All right, then the one that we missed, this would be the limit as x approaches a of f of x. I'm going to make it nice, big, and obvious, all to the power of p. So in other words, what this means is take the limit and then raise it to the exponent. Raise, let's not say it, raise the solution to the exponent. Right, so whatever that limit is, find it, then square it, cube it, whatever. Okay? Easy enough?
yes.
Excellent.
Wait, no, Mr. Can you go back? No.
Yep. No, there's no, it says on there, man. Don't ever ask me that. You can always look.
I'm gonna be missing this week.
Go look on Schoology. It tells you when everything is. Which, by the way, I have a bunch of people emailing me all the time. It's probably not you guys because you're here, but you know, if you ever miss in the future, don't bother, right? Unless you like have a specific question, just look in Schoology. It's always there.
Sir, if I am also missing, I take my bike there home.
Probably, or do it online, right? You can just do the notes. Oh my goodness, you guys, stop talking to each other and write it down, because you guys keep talking, and then you guys are also the ones that are like, oh wait. Don't tell me to wait if you're talking. You're pissing off Rebecca. Look at her. I don't actually think you are. She seems too nice. But somebody, you're making someone annoyed. Alrighty. I'm moving on. If you're not done, get it from a friend or my answer key that's posted. Okay. So this time, instead of them being equal to L and N, we're going to say that, hey, they're just 7, -4, and 2. And we're going to apply the properties, all right? So if we see something like this, even though we don't know what they are, we know the limit, we know what they're approaching, then we can still do it, right? Because in this case here, the limit as x approaches a of f of x is 7. The limit as it approaches g of x is -4. So this thing is just 3. Easy enough, right?
Yes.
Yeah?
Put 3. Do we have to put the whole?
It's a good idea for you to probably, like, you don't always have to, but it's a good idea so that later when you're looking at it, you know what's happening, okay? All right, so then for the next one here, it was 7 minus -4, so this one's going to be 11, okay? Next one, -4 plus 1 to the power of 4, which is going to be -3 to the power of 4, which all the way goes to what? Who knows?
200.
81. Good, Matthias got it.
Oh, no,
Good. Yeah, 81. Now be careful, it's positive, right? If you go and put in your calculator -3 to the power of 4, you're going to get -81. So be careful, right?
Why is positive?
Why? Because there's 4 negatives. And 4 negatives would mean that they all cancel, right? If there's an even number of negatives, they go away. If there's an odd number, it's negative. All right, over here, we're going to get 7 times, this time it's h of x, so times 2. And we get 14. All right, then they get a little bit trickier. So this one's just going to be the constant. So remember, that was 2 times. The limit of f of x was 7. G of x was -4. So I'm going to get what? 14 minus 4? 10. Am I going too fast or is it okay?
No.
We're good? All right, now this one's definitely a little bit trickier. So 2 times the limit of f of x was 7, minus 3 times the limit of g of x is -4, over h of x, which was 2, I believe. So what am I going to get here? 14 plus 12
13.
over 2. 26 over 2 is, yes, 13. Good job. Who was that? Juanse? Was that you? Or Mateo? Well, whichever one of you got it. Good job. All right. Now, look, this one looks a little bit different, doesn't it?
Yes.
Right? So, the first thing we should always do is try to plug it in. Try. Okay? Now, if we plug it in, does it matter what g of 0 is going to be? No, because what's the problem? We're going to divide by x and we're going to divide by 0. We can't do that. So we need to do some algebra, right? So let's actually write out then what this would be. So the limit as x approaches 0 of 2 times, and then copy in what g of x is. So 3x plus 2 plus g of -2. So that's going to be
-6 plus 2.
3 times -2 plus 2 all over x. Okay? So let's work that out. Here we're going to just distribute the 2 in. We're going to get 6x plus 2, or sorry, plus 4. Minus 6 plus 2, which is -4 over x. Oh, thank God.
But no. Yes, sir.
Those are going to cancel.
Yes.
And I'm going to get 6x over x, which means the x's cancel, which means ultimately I'm going to be taking the limit as x approaches 0 of 6. What's the limit of a constant?
None.
A constant. It's nothing in the sense that there's no limit to bother taking. It's just the constant.
Can I ask you a question?
Now, yes, ask questions. I'm sure you have some.
So if you go up, you're only multiplying 3 times -2 plus 2, not 3x.
No, you're multiplying 2 times the whole thing. That's why it became +4.
No, but so here we have to find the limit of 2 times g of x plus g of -2.
Yep.
But g of -2 implies 3x plus 2 times -2.
No.
Pues que el menos no lo
It means you're replacing x with -2. Okay, that's what it means. All right. Any other questions? I heard one of the girls also being like, what? Are we good? Is your whole table good? Okay. All right, guys, let's try next one.
Yes.
Here's what you're going to do on this one. You're all going to go like this. I'm not going to tell you why, but this is going to be super important. You need to know that one.
I don't know what h(x) is.
Okay? It's not h of x. Okay, it's f of x plus h, and I'm going to show you. But you guys, this is literally going to be like very, very, very crucial for the next unit. So I'm showing it to you now so that we start to see it, okay? So let's go ahead and try and apply it. So we're going to take the limit as h approaches 0 of f of x plus h, which means I need to replace all these x's here with x plus h. So 2 times x plus h squared minus 3 times x plus h plus 4. Then I'm going to subtract the entire f of x. Guys, do yourself a favor. If I am subtracting this whole function, what's the shortcut here? rather than writing a bracket and writing that whole fraction. If you're subtracting, what are you doing to all the signs?
Just change.
You're just changing them, exactly, Joel. So instead of 2x squared, it's going to be minus 2x squared. Instead of negative 3x, it's going to be plus 3x. And instead of 4, it's going to be minus 4. Because I can just flip all the signs and now like effectively add, right? So let's do that. And I guess I actually missed something, but it's because we just saw it. Simone, last time we couldn't just plug it in because we divided by 0. This time, same thing, right?
Yes.
We're still dividing by 0, so that's why we got to do some fancy algebra. All right, so that means I'm going to have to expand all this, right?
Yeah.
Now here's where we see how well you guys paid attention last year. I'll do it in 2 steps rather than 3. 2, you all know perfect squares real well, so you all know it's the first term squared plus 2 times the second term plus the last term squared. Good. I'll never do it in that many steps again. In the future, I will go straight to the next one, which is where we distribute the 2 in as well. Okay? Now, if you need to do extra steps, you do you, right? There's nothing wrong with it. But in calculus, I'm going to assume you know how to do the algebra. All right, and then minus 2x squared plus 3x minus 4 all over h. Before I even bother putting this 2 in, what can I see? What's going to be happy for us?
You can
So
cancel
that's why it's square.
Yep. Oh, and sorry, I missed the plus 4, didn't I?
But you can also cancel it by the minus.
But the 4 is also going to cancel, exactly. So I'm going to cancel out the positive 4 and negative 4, the negative 3x and the positive 3x, because I don't want to keep writing them. Now I'm going to distribute in this 2. So I'm going to get 2x squared plus 4xh, sorry, plus 2h squared minus 3h minus 2x squared. What else cancels?
the 2x squared.
Perfect, exactly, Benjamin. I don't remember, do you go by Benjamin or Benji?
Whatever you want.
What should we call him, guys? Oh, yeah. Now, can anybody, who's real good here? Who sees the other thing that cancels?
The H because you can do
The H, because it is involved in everything. So I'm going to do this again in an extra step. I'm not always going to do this, but I will do it today. So I can pull out the common factor of H, which leaves me with 4x plus 2h minus 3 over h. And now you can see how, hey, perfect, that h cancels. Guys, anytime you do this, that's the point. You have to cancel out the h on the bottom. If it doesn't work, you did it wrong. Go check your work. It's kind of the nice little shortcut here, okay? Or not shortcut, but like way to check your work. If it doesn't cancel out, you did it wrong. Go find your mistake, okay? Now, the other thing you're going to notice here is I didn't bother writing limit every time. Was I supposed to?
No.
Yes. So what I usually like to do is write it here and put an arrow because I don't want to write it every single time. So as long as you're working vertically, you can do that. If you work horizontally, you need to write it every time. Okay, but you'll notice I usually work vertically and then I draw the arrow.
Did you keep all the h and then you did a common factor?
Yep, exactly. I took out the common factor of h. Now, normally you can go straight from this step to the one I'm about to do if you want. Okay, it all depends on how good your algebra is or your mental gymnastics. Now, once I plug in h equals 0, I stop writing the limit because I've taken the limit. So I'm going to be left with 4x. I'll write it out this time, which means I really just have 4x minus 3.
When did you take the limit? When did you do that?
I took it as soon as I plugged in the value. As soon as you plug in the value, you no longer have to write the limit.
So like from the start of the equation.
Well, but you didn't.
Mr.
You hadn't plugged it in yet, because if you plugged it in, you got dividing by 0 and you weren't
the
allowed
answer
it.
Oh, so we're plugging
4x minus 3, not the limit doesn't count in the answer, right? You
No,
have to
exactly. Yeah,
put
the limit's gone because you took the limit, and that's what made the 2 times h disappear. Okay,
And the 4x stays in x because they're not asking us to plug the number in.
exactly, because they're not asking what x is. And again, next unit that'll make a lot of sense. All right, so let's do some more examples here. This time, instead of me telling you the limit of f of x as x approaches a is a number, we're going to have to look it up. Okay? So we got to practice what we've already done and use it with the properties. So we have the limit as x approaches 2 from the left of f and g. Let's do f first here. So we're approaching 2 from the left, which means I'm going to be approaching it from here, and it's up getting to 3. Okay? Then for g of x at 2 from the left, I'm approaching 1. So this would simply be 4. Does that make sense? Good. Let's try the next one. It's a little bit trickier. 2 times the limit of f of x as we approach -1. Now we're approaching from both sides. -6. Good. And for g of x as we approach -1, we get that dot there, which is at also -1. So I'm going to get -12 plus 3, or what would that simplify to? I heard somebody. I heard 2 people. There we go. Rebecca, was that you? Was that you that said it? Are you lying? Are you taking someone's credit? All right, now we're going to approach -3. So for f of x, even though the function doesn't exist here, the limit is definitely approaching something here, right? What is it approaching? Yeah, exactly, -2. And then for g of x, as we approach -3, all right, from the left, we're going up to infinity. From the right, so what does that mean? Doesn't exist. If part of it doesn't exist, the whole thing doesn't exist. Okay, if it says state y, we're going to say that the reason is because the limit as x approaches -3 of g of x does not exist because the left side does not equal the right side. Well, I asked you why. You got to remember, so Mateo, one of the things you're going to be graded on is literally just your justification. Okay, and no longer do I just want to know, do you know the answer? I want to know, do you know why that's the answer? So I will often ask you to justify your answers, okay? And part of the reason is the College Board's going to do it as well, okay? All right, we got 3 more here. 3 more? No, 6 more, never mind. All right, as x approaches 6. So I'm going to have to scroll up and down here a little bit. For f of x, as we approach 6, that's right here. What are we getting close to? -4. You guys got it.
So it's -2 times -4.
G of x, 6 is, that looks like 6 to me. Right, that point right there, that's 6. So we're going to get 8 over 6, which is, you should always reduce 4/3. What's up? Okay. Do you guys want to try the next couple on your own? Yeah, try them on your own. So I will do them. So only look up if you need support or need to check.
In the one on the bottom left that has square root, do I leave it like in the square root or do I need to simplify it?
So remember the properties. That's the same as having it to the power of 1/2. So basically just find the limit and then square root it. So find the limit times 2, square root.
Okay.
Okay? Try them on your own, guys. So x approaching 4.
Sir, we continue in 1.3.
Just do these, just finish these ones and then check your work, okay?
A ver, primero hago lo que está adentro del paréntesis o
¿Qué es penta?
o sea que resuelve paréntesis.
All right, guys, once you're done, check your work. See if you got them.
La quinta de los 20.
Don't think you guys had any trouble with this one here. The only question I did have 2 people ask me is, do I multiply g of x by 2? You technically are. Don't accidentally go 2 times -3 and 2 times 4. I had 2 people ask me that, right? Because then you're multiplying not by 2, but by 4. right? Because you're multiplying by 2 twice. Next one's pretty straightforward as long as you didn't get negative 25. Then this one is probably the one that most of you have the questions for, because you may not remember how I simplified root 12 into 2 root 3. Okay? So you got to remember that if you have a square root, you can always break it up. And so what I did here is I broke this up into the square root of 4 times the square root of 3. What's the square root of 4? 2. Okay? So you need to know how to do that, because on a multiple choice, it's never going to be written as the square root of 12. Ever. Okay? For my test or the college board, I will always simplify it. Same kind of thing here. I don't think you had trouble. Just make sure you simplify, because again, I will always simplify it. And then the last one, just be careful of the minus negative 1. But good? Any questions, or are you guys good with those? Awesome. You guys get the rest of the class to work on those practice problems. I will post the answer key as soon as it's done.